because today is a very special day. I'm not sure if you have looked at the commit. If not, I strongly suggest you to subscribe to VC-Minar GitHub. Because in this last commit, you will see, I would say, all the code that has been necessary to integrate POLKA into the VC-Minar control plane. If you spot it also, there should be some changes, some commit that relates to the to the BF forwarder, to BF forwarder, which is the interface between Tofino and the control plane. But there is also specific commit regarding the P4 code. So you will see that there is now a new ingress control. I guess it's if I recall correctly, it should start with something like IG, CTL, POLKA, something. Yes. I'm just saying this randomly. This reminds me that we will have to hold one session related to how the P4 code is written. What is the naming convention rule and stuff. So the magic here is that this week and last week also, Xaba did a very good improvement to the code, and he's here today to present his POLKA implementation into VC-Minar. So Xaba, the floor is yours, and of course you have a full hour, if not more, if you need more. So you can go ahead.
Okay. I think I am sharing my screen. Am I?
Yes.
I'm fine. I can see your screen.
Also the terminal?
Yes, the terminal as well.
Okay, thanks. So first of all, as we agreed with Frederick, I would like to show you a live demo. Hopefully it will work. The main idea now is to show some POLKA stuff in a real network. Okay, it is my favorite development router, and as you can see, it is a part of a bigger network, and I also have segment routing enabled in it. So most of the nodes have prefixes, and the main objective is to change this trace route somehow. As you can spot, it goes through my node called safe, then it arrives to my MC home main router. So the objective is to change this trace route a bit. Then let's start hop by hop. So the first hop will be the safe. That we are willing to traverse. Let's check if segment routing is enabled. Okay, segment routing enabled, that it have all the things, all the nodes. And as you can see, I checked the configs that I intend to do here. So this is why it has some packets, or sorry, bytes switched here. So it will be the first node. Then I will divert from here to my NAS. It will be the second node. Also tracking the segment routing stuff. Yes, it have. The last node will be here. Also checking the segment routing stuff. It's enabled. And the last node will be MC home. This will be the address node. It also has segment routing enabled. Now we will need the loopback addresses to list the nodes. It is 10, 10, 10, 5. Okay, I think we should start constructing the paths. First of all, disable the redistribution that I always do. My destination will be 10.1. It is tricky. I overloaded this command to list the explicit classes. So it will start with 10.10.5. Then the next node will be 10.10.20. Third node will be this guy. And I think that's it. Okay, so tunnel source, it's loopback 0, tunnel VRF, it's V1, and tunnel mode POLKA. Okay. The thing is that to have something interesting, let's start the display command on this. Show. It basically periodically updates and nothing interesting. Okay, as this guy is an egress node, it don't have this, but visible because there is no more nodes in the past, but let's see. Okay, we are forwarding V1, IPv4 address. Okay, something is working. So I am pinging constantly to this tunnel. First of all, let's see what goes on the interface. It's created some packet captures here. Yes, it is. Some control traffic. Okay, so the ping is arriving back, but it went out encapsulated that Wireshark cannot display. And this is the interesting part that we are interested in. So here is first the version of the POLKA, then the TTL, the encapsulated attr type, and then the root ID from here to there. So this is the root ID starting with 4A, etc., etc., etc. And I know it by heart. The 45 is the IPv4 beginning, and somewhere it is 1111 that is I am pinging, and it is 10.10.10A that is the source. So it's really a POLKA packet. And inside we have an IPv4 packet. Now let's go back there and let's see what goes on. Okay, so we did 4 megabytes while I was showing you the shows. The thing is that the data plane updates about every 30 seconds or so. So this is why it's not fully real time, but it updates.
It's nice. Christina, have you written a Wireshark dissector for the POLKA headers?
No, not yet, but we can do it.
Okay,
It's,
I was just wondering.
the packed header, it's just a bit different from the one we were using, so we can just modify and use it. It will for sure be easier to identify.
Okay, sure. I was thinking maybe you had already done this. Probably you have it for your own version of the header. Okay, cool. It's a nice demo.
Yeah.
Thanks.
Okay, so that's all from my side.
So that is great. So I have a quick question related to the setup.
Yes.
Essentially, what we are seeing is that we have two functions in POLKA, and I think that Christina and Rafael can confirm. We have what we call POLKA core, so which means that there is a POLKA node that is receiving something. It detects that the header is at some point that the packet is a POLKA packet, and then is doing the magic and find the egress point. So this is the POLKA core, and we have also the POLKA edge. So the node that is responsible to receive a specific packet and for an arbitrary reason decide to tag to give a route ID to this packet stream and pour it into the Polka tunnel. As you showed, it works great. And so my question is that both of the functions have been implemented.
Yes, nowadays it arrives both in P4 and both in P4. Sorry for Toshino, and both in P4MU. It all has the edge and the core functionality, and also in the software mode. So basically, yes, the only exception is the BMW2 model at the moment. That guy have no POLKA at all because I was not able to find an easy way to update the CRC module from through gRPC calls. It seems to me that it can be updated through simple switch CLI, but not through gRPC.
Yes, that's right, Xamba. We used the simple switch CLI.
But that is basically not a dynamic thing because for these test cases, I need a dynamic way to update, and fortunately it arrived to Toshino model and also the P4MU. So all these can have a dynamic ID because these different nodes that the Pocket traverses here are having different switch IDs. So, for example. Here on the template one, I have 50, that is the fifth polynomial in that I'll generate. This guy have 200, that is 200th polynomial that I generate. So this is that. So this is why I badly needed the dynamic CRC update in through gRPC to work. And unfortunately, it arrived to the Toshino in the last year.
So if I understand correctly, the Tofino ASIC has this CRC since last year, and it is possible to program this programmatically via gRPC. This thing.
Node ID.
The node
Exactly.
ID. So the node
Exactly.
ID. So it is possible to program this with Tofino, as it is a function available from BF runtime.
Yes, it is.
And for P4 runtime, this function does not exist.
Yes.
I have a question. It's a question from my side because the P4 runtime doesn't have this gRPC message on its proto file. But is it because the P4Long decided to offload this CRC function into a total independent external function from the P4Long library from P4 runtime, or can we ask them to implement this function as it is the case for Tofino?
I think yes, it was an issue at GitHub for them.
Yes,
Christina?
some time ago, I think I asked them about this, and it seemed to me that's just a matter of some feature that could be implemented in the future, but it's not implemented now. That was my understanding.
Okay, so my question is, would you be okay to create an issue at
Yes.
P4Long project? I'm not sure if it is into P4 runtime or if it is related more to simple switch gRPC. I'm not sure because I guess both have to be updated for that. But in any case, you have to update the protobuf file, so that at least this message can be conveyed from the control plane all the way via P4 runtime all the way to the BMV2.
Yeah,
Oh,
I'm
so,
almost
yeah.
sure that I did something similar in the past, but I haven't pushed it.
Yeah. Okay. So just in case, if you can raise this discussion with them,
Yes.
and then that would be helpful, so we can have all the data plane at the same level, and that would be perfect. And
yeah, do you
anticipating.
think
Sorry.
it's the regarding this issue? Do you think it would be good to ask Vladimir for some support, or because I'm
No.
not sure because
No, because the P4 long is totally different from Intel.
Yeah.
Yeah,
I have
just because
develop.
he's very active in the community. Because I'm not sure if I ask if I will have the how can I say
The
maybe
executive
Christina,
support.
maybe Christina, we should mention that they have this feature implemented into the before barefoot of explaining what it works in before in barefoot, and maybe they can implement in the future these features into the P4 runtime, something like that. So.
Yeah.
Yes,
so
maybe we can open the issue, and somebody from RARE can just confirm that it's important to have this.
we can of course we can participate in this issue, of course. I will anticipate the question. Usually when you open an issue with GitHub, and I feel sometimes the same, usually people will reply with a basic answer: would you like to contribute in creating this protobuf message and implementing this on BMV2 and in P4 runtime? So I'm anticipating the answer, and sometimes it's usually the case. Sometimes you have a developer can spend maybe a bit of time in integrating everything, but as it is really specific to POLKA algorithm, maybe they will answer with such type of question. So this is the first thing. There is also a second thing, and this is where I'm not sure. In the case of Intel, the external library implementing the functions, the mathematical functions, is under Intel responsibility, and that's the reason why they have implemented this gRPC message in order to be able to interrogate, to manipulate this external function. And this is one of the reasons why this exists right now. And maybe in the context of P4 long, they just decided that this CRC function is not part of the project, and then that it is totally external, and then it means that they won't have any, I would say, incentive to implement this message in P4 runtime, because why do they want to create a message for something that is something external to their project? So this is one of my question, but because I'm not sure, and that explains why this function does not exist. It was not the case before in P4.14, but in P4.16 they really wanted to separate all this, all things that are part of the language specification and all things that are, I would say, external, and then up to the user to do that. But in that case, the question is how to add new message to P4 runtime in order to address, I would say, external function into external libraries that are provided by the user. And this is the thing that is not clear for me.
But then I imagine that it would be the case to include these control messages in the BMV2 implementation.
Yes.
As they did in Tofino.
Yes. So maybe they have a framework for BMV2, that deals with functions into external libraries. And this is where I'm not sure. And this is where the interesting discussion starts.
Yes, that's a very good point. I will try to translate that and open the issue in GitHub and see what they tell us.
Okay, thank you. Xavier, I have another question. We saw
Yes.
you saw that on your nodes you have programmed the node ID, and
Yes.
of course there should be this node ID should be unique across the domain, the Polka domain.
Yes.
How is there a way to for example, as a network operator, I'm not super good at mathematics, but I'm just here to activate Polka, to enable Polka in the domain. What would be your approach, your best recommendation to elaborate a Polka domain and distribute this node ID?
At the moment, as we agreed with Krista, we are using segment routing indexes. So basically, you can pick any index that you wish, and the FreeRtr will compute. So let me show you how it looks like. Sorry, my bad.
Joking.
So this is the only magic command you need here. This is the node ID. This is the starting polynomial, and this is the number of polynomials it will generate from this. Basically, it's the same ending that you are configuring for your segment routing ending block, and starting from this, this is a 70-bit polynomial. It is needed for CRC60 to start at least from 64 keys, and then it will generate the good polynomials that have the greatest common divisor is not bigger than 1 for all the 260. As I saw in the debugs, it basically for 4,000 polynomials that need to be traversed and checked, but it does it for you automatically. So all in all, you have nothing special considerations for the indexes, and so FreeRtr do it for you at the moment. It generates the polynomials, and you really don't have to care about the mathematical backgrounds of these numbers. Only thing to consider is to follow the test cases and then use a 70-bit starting polynomial here. And this is the ending that this is the same number that you are configured on your segment routing configuration. So this 260, maybe I should set 300 there. Okay, it's a config back here. So those numbers should match, but that's all. It's the same 50, the polynomial ID. It is not exactly the polynomial representation. It's just an index to a polynomial table.
So Rafael and Christina, and at least of course everyone on the call, is it clear for you this how because it's very important because something something Klaba mentioned is quite it's quite important because it simplifies considerably the I would say the operation of a network.
Mm-hmm.
So let me can you show the interface again, Xaba?
Yes, for sure.
Sorry. So there is Christina and Rafael. The magic here is command is the Polka enable 50 70,256.
Basically, hopefully it have the good help text, but let's check together.
Yeah, just to confirm. So when you issue this command, then you generate a static table that links the segment route index to a polynomial that will be used as the node ID, right?
Yes, exactly.
Exactly.
And this 50, okay, so this 50 is basically an index to the good polynomial starting from 70,000, but let's check the help text. Yes, is the coefficient base, number of coefficients. So basically that's it. And it also programs the CRC engine on this interface. You need to configure it every interface because FreeRtr is VRF aware, and every interface can belong to different VRFs. It means that at least in the P4 in the P4 emulated data plane, you can have more POLKA domains on a single data plane. That is, then you can have colloiding IDs on two different interfaces, but they can belong to different routing domains, and FreeRtr then will perform the same CRC, but the node ID to next hop index table will be different in two interfaces. But also you can have different indexes on different interfaces. For example, if they belong to different routing domains.
Oh, that's right.
So that's why you have to set these parameters here.
So I can set different node ID based on the interface, you mean? So the packets goes for that interface using different node ID, for example, or calculate for the forwarding process will be different based on the interface.
Basically, yes, you can. Yes, basically you can use different node IDs, and then at that point the only difference will be that this 50th polynomial will be set to the CRC polynomial coefficient, but and you can use different polynomials or coefficients on different interfaces if you wish, but basically it's not a good idea in my opinion, except if you run two different routing domains with two different node IDs, because when a node gets a packet from interface A or interface B, it should take the same decisions, because because this different ingress can result it from for example a fast root event or so.
If I can put the same domain, all the interface, I need to set it into all the interfaces that we have here. So, for example, if I need to set the index 50, and all the packets that when arrives this interface will forward based on this node ID. So basically, I need to set this node ID only into the all interface. So
yes. If you spot it is a template interface, and all my physical interface
is like a ATH0, ATH1, and so on.
So basically, all the bundle sub-interfaces, I only use sub-interfaces. So all the routing interfaces inherit this template.
Oh, okay, understood.
Okay,
so I have the SDN interfaces. Basically, I have the so my whole network is basically a set of VLANs, and this is where I route traffic. And this is bundled because the physical interfaces, I mean the SDN interfaces are just bundle members. So if
okay, so you set the members like a group of interface. Okay.
Yes, so basically it's a Linux team or LACP or anything. So basically, I do everything over bundles and sub interfaces. This is why I badly needed the output port to next hop, because it's a sub interface, and basically these bundles are connected by real switches. So I also needed the MAC address rewrite. Otherwise, I saw that it didn't went out.
So Xaba, just sorry, Xaba, just again to take it to recap again. Can you show me the LSRP segment routing configuration?
Yes.
and on the same screen, and then show the Polka configuration. I just want to Christina and Rafael and the others to really understand how to configure Polka. Okay, great. So now, if you see here, Christina and Rafael, here you see SegRoute 300. 300 is the max index.
Yes, and this guy should be 302. It is a config issue
yes,
here.
Yes. Don't worry. But here SegRoute 350. What does it mean? Basically, in your case, imagine you are a network. Let's imagine you are a network operator and you have 300 router. Okay, you have 300 core backbone router. Then the max index can be 300. This is the max index. So you can have. Is it starting from 0 or from 1 already, Xaba?
I think 0 is reserved in segment routing draft.
So yes, sorry. So basically you have 1 to 300. So you have 300 routers. Now the second number 50 is the index of the node having. So you designate exactly. So what does it mean? It means that in all your domain, your LSRP configuration for segment routing, and it will be the same for OSPF or ISIS. You will have this SegRoute max index, which is 300, and the index number, the node, what we call the node seed of the node of the equipment. So here it is 50. If you want to create now a node, a relevant node ID that is corresponds to the node, the magic command is Polka enable the index of the node, the segment routing index, the 70,000 coefficient that is sorry.
That is the starting coefficient.
The 70 bits, I think.
So it's 70 bits, yes, because it is needed for CRC. I played a lot with it, and this was the original conclusion of my first some emails that my CRC is not working only with polynomials. So I didn't realize that the degree of these polynomials should be bigger or equal to the CRC60's degree, and the degree of CRC60 is always 760. So I should pick up 70 bits.
Okay, thanks. And then the last field, which is 256 here, is an error. It should be 300.
It's a config bug, yes.
But it should be 300, okay. And then by creating this line on an interface, what you just did is that you have enabled Polka and you guaranteed and you give your node a node ID that it has no collision with the others, simply because the index is different. So basically, what Xaba created here in his Polka philosophy in terms of implementation is that there is 3 inputs in order to create a node ID for a node. One is the segment routing node seed, which is 50. The number of bits here, which is the 70,000, and the max index, which is 300. With this free field, you will get your exclusive node ID without any collision in your domain with 300 routers.
Yes,
sorry.
That's brilliant.
Is it okay, Xaba? what I've said? I'm just trying to make Rafael and Christina familiar, because maybe segment routing or not, this configuration is not familiar to you. So this is great.
Yes, the summary was great. Thank you, Frederick.
So what you have to, if you want to replay the same demo, you create, you spawn in your VM now that you have read the FreeRtr documentation. I'm pretty sure you can spend 10 routers in your laptop, and then you can configure Polka, and you play with it, and you will see which node ID has been allocated, and so. Is it possible to is there a show command that would give us the node ID based on the Polka enable, the 50 to 70,000 and 256. Ça va?
Basically, not too much. Only this SR index that I am showing you.
Okay.
This show command. This is the same index that is used, and not
okay.
So there is no specific for the interface level.
Okay. So this is the first question I had. So now that we have solved the node ID, I would say collision into the entire domain. I had a question. If
just one more thing, I got into the idea. So basically, I sent in the mail, but let's do this again. There are the test cases that we have, and we have also a lot of POLKA test cases, and basically that's the magic to start a test case. It's POLKA over Ethernet, and at this point, it starts and executes the tests. I think I sent it in a mail, but it not causes any harm if we redo it. And basically, it will stop here, and this is the effect of the wait keyword. And at this point, we can turn at. We see that we got 3 routers here, so we can turn at localhost 20,001 and 2 and 3, and they are the routers. And here we have an IPv4, IPv6 segment routing domain, and also it has POLKA enabled. And as they are executed in software mode, so we can spot that we have some POLKA packets here. And if we spot, we have tunnel 1 and tunnel 2. Tunnel 2 have tunnel 2 have the specific thing that it is IPv6. So basically, this guy uses the IPv6 segment routing indexes instead of IPv4 and computes the root ID from these indexes. And basically, it's an IPv6 payload also in POLKA. So if we ping here, it's IPv6 packets. And we can do some crazy tests, and it is much faster than pinging 1111. And at least, okay, let's have this ping running forever, and also let's find out what happens on this guy. So we can see that we have 400 megabits at the moment, I think. Let's see. Yes, it was. Yes, because it that was the one direction. Yes.
Are these nodes using the POLKA routing, the tunnel?
Yes, these nodes are using POLKA to route the tunnel, and we can confirm it by issuing. Basically, let's do it also with display. So basically, all the POLKA packets are increasing heavily in both directions. So basically, that is the test case with the wait keyword is useful. And if I stop it, then also the packets counter of POLKA stops increasing. And as soon as I start it again, then it starts increasing. And I think we can ruin the experiment a bit because
yes,
we can ruin. I think we can ruin the experiment a bit because I can set a different different node ID, for example. Okay. So basically, now I think I have ruined the packet path, and it was 2. Let's do it with 2.
That's great.
We can spot when it halted the traffic.
Came up again. Yeah.
I didn't play do fool. Okay. So basically, yes.
So it seems that your research paper has found an implementation.
Yes.
Yeah. Yeah, we are very happy. It's it's like a dream. Yeah, it's very nice to see that theoretical paper in practice now, and all this brilliant work you guys have done to integrate that in PRERouter and RARE, and it's working.
And yes,
We are
it
very
is
happy.
working very great.
Thank you very much, Xaba.
Thanks for the great paper and the great idea.
Yeah.
Because I really love this idea that having a fixed header and do some mathematical tricks to have the routing decisions, it's much better than they are doing now with segment routing and the variable length headers.
Of course, yes. This variable length header, it was an issue because this has some impact on the hardware, and of course you will have to pay a little bit more if you want larger header. So many thanks, Saba, for this demonstration. Yeah. So
I have a question.
Yes.
Yes.
Yeah, for Saba and Frederick. So the original conception for the POLKA was based on a centralized controller that would distribute the IDs to the nodes. In Saba's implementation, he did it locally, right? And then he did it by each interface and bundle them as a one thing, and as a one POLKA router. Is that correct? And then my question is, how does he guarantee that the index is not reused, the index for the table? So every node has a table, and he points to the index for the polynomial that will be taken by that node. And how does it implement a kind of certification or a consolidation of indexes across the domain? That's my question.
Very good question. So basically, it's always up to the local network administrator to do things in a proper way, and it is written that segment routing indexes must be unique. But let's see what happens if I set segment routing index 1 here. It is basically should log somewhere something, but let's check. Okay, I think I should log somewhere. This is an invalid index. This was the other configuration. Okay, so it's always up to the network administrator to not do things like this. To have yes.
Sorry, this is Jordi.
You have a protection.
If I'm not wrong, we have already netconf implemented in PRERouter, right?
Yes, we have.
It would be possible to do this index configuration from a centralized point, as Moises was suggesting, somehow.
Yes, we can do via the centralized configurations via netconf or any other configurations. I think we have Young also.
So Moises, in order to answer your question, what Xaba demonstrated is the basic way telco.
Okay, so at the moment, I checked that root ID, duplication root ID is logged out, but duplicate segment routing is not logged out. So I think I will add this sooner or later to at least warn the operator that okay, guy, but you did some collision on the segment routing IDs.
But sorry, Moises, just to complete the answer, basically PRERouter has already all the some APIs to configure the node remotely. So it can be up to a central controller of your choice. If you're familiar with netconf, Yang, TCL/TK, or other way that help to configure remotely FreeRtr, this is already possible. But of course, it is this is the responsibility of a global network administrator to do that. Nothing prevents someone to configure manually a router. And this is why by having chosen this way of doing things, you can automate it using a central way, or you can just distribute it using, you keep the distributed model here, following a specific global engineering rule when you are implementing your router in your domain. And this is the idea of what we think it's the best way to move forward, because it will draw a clear line between the umbrella system, which is what you call the SDN controller, and the node. So you have the flexibility to have a distributed and to have the centralized control. Whereas in some models, everything is solved with the equipment and the controller, and you can't separate each other. In this case, you have all the choice you want. Does it answer our question, Moises?
I think, go ahead, Saba, please.
And one more point. So in your paper, you are suggesting the controller because you are using very tight polynomials. So you use 110 and 1101, and the output ports must be also lower the degree, so the modular division can result within the range for the node ID. But as I saw with the experiment, I set the starting polynomial to a very high value. It is basically a very high value. It's 70 bits, and I pre-generate the good polynomials locally. So basically, the node idea here in the configuration is almost as static as the segment routing index. So basically, you really don't need to reconfigure this node ID, and I mean the polynomial for the CRC. You only need to configure the headends of the tunnels, and basically the headends, as we discussed before, can also be static because there are some tricks here. So, for example, in tunnel 1, now I have only the 333 network pointing to tunnel 1, but I can do, for example, outer routing, and then I can outer route traffic with source router. It should be good to know the ID. I think it is 2223. Next hop is maybe 333, but 3332. And let's see now what we have got now. Now the loopback automatically returns to this guy. So basically you can have outer route to have routes to the tunnel. Now I redone it, so it now only Ethernet. It points to Ethernet, but beforehand it pointed to the tunnel. Or also you can use policy-based routing to route specific traffic to the tunnel. For example, access list ASDF, permit, everything. And let's do the toss value again. And now the other experiment will be to ping. Okay, but at the moment, I think I don't have anything.
This is an edge node, Xaba?
Yes, basically it's an edge node. R1 is an edge node. Okay, now I think I need another additional loopback. Let's see if it happens. Okay, I think I need to enable it. Let's see if I have the route. I have 1, 2, 3, 4 now, and now the outer route again. It's somewhere there. It's almost there. Forget about policy routing, I think. Yes. Recover. VRF. Next hope. 3332. Let's see if it works. Let's see what's going on. I am on R3, so go back here, display interface Ethernet 1, enter type. Okay, at the moment it is arriving with POLKA, but why? Common differences. Ah, my bad. If I policy route, then I don't need the outer route. My bad. Yes. Right.
So you mean that there is an administrative distance between autoroute and policy-based routing? What is the one that is preceding the others?
Basically, when the route points to the tunnel, then you cannot do anything about it. So at the moment, I am transmitting with MPLS. MPLS unicast is increasing. Now I already changed the task to 1, 2, 3, 4, and it does not work. I think something is wrong with this PBR. It's policy routing to the tunnel. Tunnel.
Saba, while you're
Yes.
trying to get your things right, can I ask Frederick a question?
That's for sure.
Moises, just to summarize the answer, we
Yeah.
are reusing the segment routing indexes, so we can rely on all the distribute protocols that assign the unique indexes to the nodes.
Right.
So when we do that, the suggestion from Saba is that we inherit all the features from the other protocols because we can use these unique IDs as our node IDs. We just have a table that translates this ID to a polynomial.
Right.
And when we do that, then we can, all the magic happens because we already have the unique node IDs assigned to the nodes reusing these distributed protocols. And the centralized control plane can then just be in charge of calculating the right route IDs because the node IDs were already assigned and they are unique because of these traditional standard distribute protocols. So in our case, we are reusing the segment routing indexes.
Okay. And also, I got part of this answer from Frederick. Thank you, Christina, for complementing that. Mm-hmm. And also, I think Frederick mentioned that if you can do it locally, we can do also it centrally using the remote access tools that are developed for VC-Minar. So the role of the control plane can be played by this remote access.
I won't say remote access. You have APIs, and these APIs can take the form of transport protocol like netconf or TCL script or SSH or an other means to configure the router remotely via APIs.
Right.
It's not remote access per se. I think you have even have a PSEP interface.
Yes, yes, there
PSEP
is.
server. So you're not limited in central. And if you want, it would be a great exercise if at the UFS side you can have a central server that would compute all these NOD ID using this segment routing paradigm, and you can, and with a beautiful map we can show something. But it can be a good exercise, Moises, if you have some student or that you can allocate on that task, for example. Yes,
Okay.
Saba?
Very good
Anyway,
point.
I have figured out what was wrong. So this is my current config above the regular POLKA test. So now I am matching exactly because I created the routing group. So now I am pinging with TOS 1234, and and now the MPLS traffic is increasing on this interface. And now I switch back to, oh, sorry, bad window. I am switching to 1234, and now POLKA is increasing. So basically, you can pre-build a lot of tunnels. You can auto-route, and then you can PBR. Basically, you can do everything with that you can imagine. Also a centralized controller, but for that, instead of directly applying configs via netconf, my best guess is that we can use PSEP. And I think it already, I don't have test cases at the moment for PSEP with POLKA, but I think we can apply it, and I can apply some test cases because it's not too hard to test it out, and it's the IETF way of centralizing controllers at the moment.
Well,
but yes, you can do static routing to the tunnel. You can policy route and auto route and so on.
Yes, just a small compliment, Xavier.
Yes?
I would recommend to Christina, if you really want to centralize something, try to do things with the IETF way, like PSEP. That's a very good candidate. Another point I would like also to mention is for Carmen. Carmen, if you have looked at the demonstration, the last demonstration with PBR, it is the use case you have requested from the CERN. Basically, you are identifying the flow, and then you are able to pour the traffic, to redirect the traffic into a tunnel. In this case, the tunnel can be an MPLS or SBB, but it can be also segment routing, SRT or SREXT, as Xaba showed 3 weeks ago. But now it is a POLKA tunnel, which is great because also this can be, because I'm not sure if you are familiar with POLKA, and then I suggest you to read the famous paper from Christina and Rafael. This is a very great way to if you need some sleeping pills. No, I'm kidding. I was just checking if you were not sleeping. No, that's great. No, that's why people are laughing. But no, I'm kidding. But this is a great way to have entryless forwarding based on the combination of cleverly allocated node ID and route ID. So the idea is that, for example, if at the CERN, from the CERN point of view, you have different flows, you can allocate them different route ID. You don't have to consider the IPv4 flow labels. You just allocate route ID, and then you let the backbone to do the rest. And then from your central, if you want to do it centrally, you can have a server listing all the route ID that would correspond to a specific POLKA tunnel, and then it will reach the tier 1 or tier 2 computing center of your choice from the source point of view. So Carmen, if you have any question afterwards, I'm pretty aware that it's a little bit fast. Feel free to reach us, and we can close the loop in that.
So basically, you're saying that this could be another different solution.
It's not a different solution. It's not a different solution. It's the same solution, which is qualifying the traffic policy-based routing and put the traffic into a specific tunnel. But now, instead of having a new MPLS or a segment routing tunnel, we have a POLKA tunnel. And this tunnel is here to convey packet from, I would say, provider edge point A to point B, which is a transport which let you decide what is the path of the transport. So it's a hybrid. It's a combination of something that you suggested, and another and what Christina and Rafael was suggested. So by joining the two, we have a complete solution that is, of course, different. And also, just to let you know that I have started to read a little bit of existing RFC in order to structure, to provide you a right outline regarding the RFC, because I'm not sure what would be the good structure if we just focus on the path calculation. But the thing that is interesting from the IETF point of view, at least from my perspective, this is what I feel, is how operationally it can fit into existing network, like what Xaba did, that suggested was great, by just providing, by just reusing the segment routing and index, and then leave this coefficient calculation totally hidden from the network operator's point of view.
Frederick, I don't know if we still have time. I have some questions for Xaba.
Yes.
I'm very happy with all this implementation and see that it's working. Regarding Moises' question, I think that for the core nodes, the interaction between the control plane and the controller, a centralized controller, is very limited because we only set the node ID. So I think the distributed protocol for that purpose, it's okay. I cannot see a specific reason why we should set that in a centralized controller. But when we think about the root ID calculation and the edge, I would like to understand a bit more how Xaba did the implementation at the edges to decide the path and calculate the root ID and to encapsulate the root ID.
Let me show you and give some explanation. Okay, the time expired. Okay, so this wait command only gives you 10 minutes. So here at the edge node, not template is tunnel 1 and tunnel 2. So here in the edge node, you set the tunnel destination. This is the other end of the tunnel where the path will be sent, and this is the intermediate node. At this topology, we have all these three routers, so it only one listed. But on my live demo somewhere on my home network, I think it was this guy. No, this guy.
How many hops do you have in this test?
So in this test, I use 3, 4. It depends on the test. Not sure that I am using. Here it is 3 nodes in this POLKA 01 test. But in my home network, it is a bit bigger, and I think it is easier to explain here. So this is the tunnel destination. This is the other egress node. It is a specific because I will tell you some different thing about this. They are the intermediate nodes that should travel in exactly this order. Back to the test case. Here we have only one intermediate node. This will be encoded in the tunnel. In the root ID. It will be it will present as a value. So when you divide back with this guy's polynomial at router 2, then it will get a valid result for it, and it will point to node ID 3. Node ID 3 is a bit different because it also will get POLKA encapsulated traffic. Let me show you. And at this point, I am going to R3. Yes, so I am getting full POLKA packets at all. But this is the end point of the tunnel. This guy have to conclude that it do not have to forward somewhere else, or so it have to process it locally. For this reason, I encode the 0 polynomial. So basically, when R3 divides back on the POLKA packets, then it gets a 0 for the reminder, and at this point it knows that it has to route locally or do something with the packets. Let me show you it in the source. I think it is much easier to explain this way. So here in the source 3, we have that VC-Minar interface, and we have POLKA somewhere. Yes, we have POLKA. Okay, so this is how we decode with the polynomial class. So this guy uses the polynomial class and do the division and get back the value. We have also a way to do it with CRC. So we just need initialize the CRC calculator, put back every bytes but the 2 last, and then do the XOR with the CRC value. Yes, and basically the forwarding decision. So when back to this code. So when we here. So when we get the packet, we decode it fully and call back to got POLKA packet. Let's see what this guy do. Okay, got POLKA, the IP MPLS. Okay, so here we basically call back to get the root ID. It's implicit from the CRC. It's the CRC function. Basically, we have some debugs. Very nice. We have some debugs, and then if the reminder got 0, then we basically forward the packet back in an MPLS header and do an MPLS receive on the packet. It can do it can have an MPLS or a letter type for IP or IPv6. If it was not the case, so basically we got anything but 0 after the division, then we basically check up that explicit ID to the neighbor or next hop table. We check if we get that value. We log out if we get an error, and if we got the next hop, then we basically send the packet out with the next hop, and that's the forwarding decision. It basically so when I construct the root ID, and at the moment I implicitly inherit the outgoing port because it's just a list of nodes, and if I want to encode the path 1, 2, 3, 4, then I simply set the output port for 1 to 2, for 2 to 3, and the 3 gets output port of 0, and this is how I encode at the moment with the POLKA. Basically, it's somewhere there. Okay, generate. Yes. So and this is the output. This is the output port list, and everything. So if I want to encode for node n, then I get the n+1 node ID and encode that. But if I reach end of the list, then I simply return a 0, and at this point, that guy will know that he has to forward the pocket locally. So back to the test case. This is how I have only three nodes, and I can test it with one intermediate and then two addresses, because RC also have a POLKA tunnel. If you take a look on here, it also have a POLKA tunnel, but at this point the tunnel destination is node 1, and the intermediate is the same node 2.
So in this example, only node 2 is executing the POLKA routing, right?
No, R3 is also executing debug.
I think all they are executing POLKA, but one is doing the edge procedures as well.
Yeah, I mean, yeah, the call forwarding based on the CSC, it's executed only on node 2.
Node 2 is executing the CRC, but node 3 for also executing. So as you can see here, it also gets a POLKA packet, but the reminder is 0 here.
So it's end of the path.
Yes, so basically it's end of the path, but it is the same. It is the same route ID, so nothing changes here. But in terms of pure core nodes, then only R2 here is pure core nodes. So debug guy face POLKA. Here, let's undebug. So here the 2 concludes to something meaningful except 0. So this is why it immediately forwards. But R3 is also a core node in terms of that it gets the POLKA header and executes the CRC calculation, but it concludes to 0. It concludes to 0 here.
Yes. And in the node 1, when you encapsulate it, it's the one that encapsulates the root ID, right?
Yes, here in tunnel 1, it encapsulates the root ID.
And does the remaining of the vision?
It only so this so when I send out one packet here, then this guy only imposes the POLKA header. So it is an ingress node. It calculates the root ID for the POLKA header and and imposes the POLKA header, but it does not execute the CRC because it don't have to. It well knows that I have to impose the header, I have to calculate the root ID, and I have to send to that neighbor. It's an explicit forwarding, and this guy obviously does not put itself to the root ID. It does not set the node ID into the root ID, the self node ID, because no way that he can get back the packet.
Yeah, and how it calculates the path? If I, for example, if I have a longer path and more hops, so how it translates the destination and calculates the path and then the respective node ID.
I see. Let me show you with the source. I think it is much easier. It is client and POLKA here. I think it must be in the ending because this is the interesting part. So when the root ID needs to be calculated, then it gets the targets. It is the list of IP addresses in the tunnel you configured here. Let me show you here. The tunnel domain is gets translated to IP addresses, but on my home network, if it still runs, it's a much longer path. So then these IPs populated to this targets list. Then this guy tries to find the indexes in the segment routing index table. So this guy tries to find all the prefixes in the octal routing table and checks if that guy have a route and have the prefix, have the segment routing index. And it prints out an error if it cannot find every hop in the pass. Here is the pass, here is the pass, and here is the segment routing index table. When this guy populates, okay, and basically it builds an IDs list. It builds an IDs list. And at that point, when the IDs are built, then somewhere, yes, it checks for the last hop. This is the tunnel destination where it has to encode a 0. And finally tries to encode encode. This is the list of coefficients that you already configured on the interface, and this is the IDs list. So basically here happens the calculation for the root ID. This does all the math that we did, and it gets back the root ID. It's the 16 bits. And later, when this tunnel interface wants to send the packet, where is it? Where is it? It is here. So basically, it only sends the pre-calculated root ID. Internally, I reused beer because it's also a big array. Okay, it sends the protocol. It is the first byte of the packet. It's a FreeRtr internal stuff. It maps out the TTL or sends the constant TTL, and then finally it sends the packet.
Great. So in that command line, you define all the nodes that you want to be part of the path.
Yes,
and then it will calculate in that tunnel definition you showed us. You define which are the nodes in the path, and then you pass as parameter in this function, and it will calculate the root ID.
But
exactly.
But how do you define the output port though? So you don't define output port, or you maps for
you define
index?
the next hop.
Yeah.
So basically here.
I don't know if there is an index to the next hop for each node.
Let me show you with this example. So it is 5, 20, and 199. In this table,
so this is the path, right?
Yes, this is the path. So in this table, it is 5. It must be somewhere here. It is 50. So I will code for 50, and it should do the division, and it will be the next node, which is 20. So this guy will have
a list of index.
Yes. So this guy will encode for 20. So it is 20. Where are you? Where are you?
So actually, you encode a list of next hop indexes.
So basically, I only encode the next hops. So guy 50 will encode. So for guy 50, I will encode the 20, which is
20 is 200.
I can spot it. Okay, 200. For 200, I will encode. It is 199. Where are you? 199. I cannot stop. It is there.
199.
Yes, 199. And for 199, I will encode the tunnel destination, which is 10, 10, 10, 1. I think it is in the beginning. It is 10. And for 10, I will encode 0. So this is what I will.
End of path.
Yes, this is the end of path. This is what I will encode. So for polynomial 50, I will encode 200. For polynomial 200, I will encode 199, and for polynomial 199 encode 10, and for polynomial 10 I will encode 0. So and then every node when it quotes the packet, then it looks up its local neighbors, and it knows that okay, I have a neighbor 199, then 199 is a directly connected neighbor, and then it will be able to pick up next hop, a direct next hop.
Yeah, that's a very elegant solution. I think it's very nice. And
And just
in
a
the
moment,
case
and that next topic can point to arbitrary interfaces. So I already have test cases for POLKA over GRE and so on. So every encapsulation, we have a saying here that encapsulation is like Pokemons, you have to catch them all. So so basically, in this way, POLKA works with all the encapsulations.
Yeah, that's nice because then you can enable both what we call strict source routing and loose source routing. Because if it's not direct connected, then it will use another way to route the packet to the next known hop. And I'm just thinking that it's you said in the previous meeting that for segment routing you have a limit of 4 hops to define the path.
Yes, on low end box is 4.
We could show in a demo that we can do with any number of hops if we use the POLKA tunnel.
Any, I think it is a too big number. As I saw in the experiment,
more than 4.
more than 4, much more than 4. If I remember well, POLKA with 128 bits, I was able to encode 8 hops, which is much better than 4. But I think if we increase the 128 to 256, then I think it will be 60 hops. And the CRC and all the underlying mathematics is the same. And basically, so you don't need to be afraid of big headers because, for example, Beer also uses 256 bits by default, but that guy can operate with 1 kilobits of of header also. So
yeah,
maybe
we could change the CSC. So if we use 8-bit CSC or 16-bit CSC, it depends on the target, but we could change the number of bits of the CSC and change the size of the header.
I see. I think CRC60 is very good because 200 and so if we go with CRC8, then we will be limited to 256 nodes, which is not that much. If I can show you some crazy guys from Giant. They also went crazy about segment routing, but they configured it a bit differently. What?
Because if we use CSC32, then we would have even more nodes. So it's also a possibility.
This is Giant's internals, and they are using a much bigger segment routing index range. So they started somehow with 4,000 for IPv4, and they start with 6,000 for IPv6. So if we reuse the same logic, we cannot encode these big polynomials with CRC8. So it would be a bit if you use.
Yeah, we would have to use a constant.
Or subtract from some number if we decide to use the Giant IDs. But again, so basically,
maybe we would have to have a constant in the index just to, because it seems that it's a constant plus a number.
Yes. So they started with a constant. Yes. So basically, we can subtract 4,600 here because they are using it. So back to CRC60, I think it is a good decision. So I like it because we can encode arbitrary big polynomials with this CRC60, and also segment routing allows us to very, I think it is 8,000 that is the default limit for segment routing indexes. So CRC60 is fine decision here. Maybe a bit bigger POLKA header, but at the moment 8 hops is also fine. So especially
yeah, because
if,
in the when we present the paper, many times people ask about the size of the header. So it was a concern of us if this is in operation, if this is a problem.
in course, basically everyone runs with the jumbo frames at 9,000. So 60 bits or 32 bits does not change at all. Especially knowing that the internet traffic is still 100 and 5,000 in NTU, and the cores are 9,000. So we have a lot of space to to use big headers.
Oh, okay, that's great to know.
But it's basically a small decision here. So basically, all the route ID are transparent here, and I think it is only one or two places that to be changed to use bigger or smaller headers.
Okay, it's good information for us.
Question, Xaba, can this change can be in parameter? I mean, can this be changed on the fly, or should we recompile or modify in harder code in order to use a bigger header, 64 instead of 32, for example?
At the moment, it is hard coded, but it can be parameterized obviously if we need. But one should pick up one length, because in hardware it is not too easy to use these parameters in the parsers. So I think the 100 and so basically beer also defines a lot of bit lengths, but it is written in the beer RFC that everyone must support 256.
That's great. So any more question, Carmen? No, that's perfect. We'll see how this can fit your new test case with the CERN. That's really great to have this. Christina and Rafael, what I propose is, and Moise, is that you look at the code safely before sleeping again. And then I think you have spotted the commit. Obviously, Xaba put the commit on the RAR dev mailing list, so you will be able to see the big difference and compile maybe a whole change of the code related to POLKA integration into FreeRtr. That will be great. Xaba, I have a good news for you.
Yes.
Because Christina and Rafael proposed us to create a kind of material in order to make people to get people on board in order to add something like POLKA. So basically, this is the idea would be to okay, we have something that I want to integrate into FreeRtr code, into the P4 code. What has to be done, and I guess this is one of the idea to give the tribute back to you, to your work, so that it can foster more dissemination and at least vulgarize the difficulties to integrate new features into the code. Sorry, Rafael, and Christina, if did I said things well correctly?
Yeah, we were trying to understand how we could document this process, and but the whole idea is to ask you if there is some kind of effort that we could do to pay back all the effort you had to integrate this to VC-Minar and to RARE. So the first idea from Frederick was to write the RFC in conjunction, and also we proposed a way to document this process of integrating a new protocol to RARE, but I'm still not sure from where to start. And so if you have any ideas, I think the first thing we would like to do is to run to try to reproduce this kind of demo that Kisaba presented us, but also something that we could do is to try to document these modifications, but we still are still not very sure how to do it.
Okay, so if you are not sure about some technical point, just feel free to reach us. We and get back to us. We can, of course, answer all the questions that you can raise on the mailing list. Again, mailing list will be the best way to interact, so people, everyone can jump in and help you. In that with that respect, also. What is really important is that you collect I would say the last 20 commit and keep the commit related to Polka integration from the very beginning all the way to the start. And if you have at some point some difficulties to identify where it started and when it stopped, feel free to again reach us. And then you can document step by step why and how to map it with your paper, the Polka logic, and how this can be done. I think the best way to start is to collect this commit and step by step map it into the process of how Polka should be operated. In turn, you have two things. You have how the data forwarding path, how a packet will be forwarded, and you have also the signaling path, how to establish to configure everything, to set up everything so that the whole system can be Polka enabled with a specific node ID and so on. So I guess that would be the way forward. And again, what I'm doing now is that I'm trying to read and provide and propose an outline so that we can at least stay relevant, at least from the IETF point of view. It's not very it's not very tough, but it's fairly, as it is a fairly new exercise even for us. But I think it will be rewarding to have something standardized.
Yes, we agree. I think it's a very good idea if we can generate these RFC and select what it's the important focus and information to put there. I think it will be a very nice contribution. We will be very happy with that.
For now, I will really focus on the content. So it can be a text file or using VI or Emacs, whatever. And then we will think about how to put it into the RFC editor and so on, which can be another step. But I guess we can start with that.
Nice.
Yeah.
The other
and
things
in
maybe
parallel, we will try to reproduce the demo.
Yeah.
I have sent you the magic commands on the chat, and one of the mails I sent you the instructions. So basically, it's not that hard to download the VC-Minar package and then execute that one, and it will spawn up you the routers. You can find in the commits that you can pick on your favorite routing protocol or a bigger topology or anything. And if you take on the test cases, then I think you will get the idea that, and you can add more nodes if you want to experiment a bit more. It's and feel free to ask if you stop at some point.
No, and also if we identify and create some figures, and maybe we can try to reproduce what Kisaba has done here. Maybe we can create some figures explaining the whole procedures to add a new route ID and remove, and to understand like using big pictures how the process works internally. So it might this is
Yeah,
I think for our side it would be good to understand the whole process using like document it properly, so put some figures and so on, and also would help us to understand what Gesaba did, you know, as well. What do you think, Christina? This documentation for us.
yeah, I think it's nice. We can produce a kind of
Yeah,
tutorial like documentation.
yeah.
I think it's a nice idea, Rafa.
Okay, then. So that's. I'm glad to see that we have all our homework, and I would like to thank you all for being here. Alan, again, I hope that it was not too far away from what you were expecting. What I was mentioning is that of course, we can pursue this discussion next week. What I will do, if you are okay, is that I will also do my homework I will see if I can do this next week or next week, but I will reproduce the same experiment, but now with the P4 lab. And then and then we will have representative European footprint in order to test Polka. And the good news is that maybe with Carmen we will have 2 additional nodes in Geneva, and also with this week we have also, you had also the possibility to reach the US, Chicago. And Trinity College. So all of these have been fully integrated. So I will try to do my homework and activate Polka alongside RSVP and create different tunnel and do this magic traffic policy-based routing with the help of Carmen P4 switch. She has a P4 switch, and also send traffic from our DTN. I should have a new DTN in Chicago this week, so I will keep you posted. But maybe next week, if everything goes well, we can real quick do this this experiment and show this to you. And even if you want, you can also do the test yourself, because I think you still have access to the lab. Or we need to reestablish your private SSH, your public SSH key on the user bastion, but we will see that. Thanks to all for being here. It was a great pleasure, a great session, and obviously we have crossed the 1 hour session by 40 minutes. So sorry, but I think it was really interesting to have this discussion all together. The important note is that I think that Moises will try to find someone to create this SDN controller based on PSET in order to create his Polka domain with the help of Rafael or Christina.
Okay. Thanks for the assignment.
And Saba, any final words?
No, nothing from my side.
So thank you all for being here, and I'll talk to you next week.
Bye bye.
Bye.
Thank you
Okay,
very
see you.
much.
Thank
Okay,
you.
bye-bye.
Thank you very much, everyone. Bye bye.